Okay, hi everyone. We are starting our next section on the quadratic formula, which is another form of factorization that is going to be used when you really can't solve a quadratic using just sum and product or splitting the middle term or removing a common factor. So this form, using the quadratic formula, would be an alternative to completing the square, which was the last method that we learned. All right, so what we do with completing with the quadratic formula is we have this formula, negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now, notice that in front of the x squared you have a value of a, in front of the x you have a value of b, and c would stand for your constant. Okay? Now, if I had a question similar to the one that's right here, 9x squared equals 6x plus 1. I'm just going to erase the solution here. Okay, so if I had 9x squared plus 6x plus equaling 6x plus 1, the first step I would take in trying to solve this would be to bring everything over to one side of the equation so that it is set equal to 0. So that we would have 9x squared minus 6x minus 1 equals 0. All right, now, the next thing we want to do is, because we have to insert or substitute the value, some numbers or values in for a, b, and c in the formula, then we need to determine what the values of a, b, and c are. So I start looking at the value of a. The value of a is always going to be in front of the x squared term, so it's in front of the quadratic. So I'm looking at this problem, I know that a is equal to 9. And then if I look for my value of b, well, I see that the value of b is always in front of the x term, or the linear term, so it's right here, our value of b. And this turns out to be negative 6 in this problem. And then the last term, the c, is our constant, and the constant is going to be equal to negative 1 in this case. All right, so our goal at this point is to insert all of these values for a, b, and c in the given formula so that we can figure out what the x-intercepts are, or we can solve for x. All right, so let's take a look at, we've got negative b plus or minus the square root of b squared minus 4ac, and that all gets divided by 2a, and that's our value of x. Remember that x stands for solving for x, but it also stands for finding the x-intercepts of the parabola. Okay, so we'll start off by replacing in negative 6 for b. So because it's a negative 6, and because it's a negative b, this will go to negative 6 plus or minus, and we'll say negative 6 squared minus 4 times a, which is 9, times our value of c, which is negative 1, and we divide that all by 2 times the value of a, which is 9. Now, the only thing left for us to do is just to solve for this. So we'll say negative 6 is positive 6, and it's plus or minus. Negative 6 all squared is 36, and then we have minus, and we've got 4 times 9 times negative 1, which gives me negative 36, but it's minus, so it's plus 36, and that gets all divided by 18. The next step is going to be to get 6 plus or minus, now we have the root of 72, and that's going to be divided by 18. Last step, or second to last step, is basically simplifying the radical. So we'll say 6 plus or minus, now this is like saying, I'll just put this off to the side, root 36 times root 2, which is really 6 root 2. So it's 6 plus or minus 6 root 2, and it's all divided by 18. So that, because 6 goes into 18, and that 6 also goes into 18, then I could say that 1 plus or minus 1 root 2 And I don't have to place that one in front of the root 2, but I choose to. And I divide that by 6, so that we end up with a 3 in the denominator. So I divided the two terms up in the top by 6 and also the bottom. So 6 divided by 6 gives me 1, 6 divided by 6 gives me 1, and 6 into 18 goes 3 times. And therefore my answer is going to be 1 plus or minus root 2 over 3. And we have two solutions, that means, right? So it's x equals 1 plus root 2 over 3, or x is equal to 1 minus root 2 over 3. It is sufficient for you to just give me your solution here as 1 plus or minus root 2 over 3. You don't have to divide them up if you don't want to. All right, let's just do another example. I'm not going to make this a long video at all, but let's take a more difficult example, such as x plus 1 over x equals 3. Now here, because we're trying to do ax squared plus bx plus c, I can't do that because I don't have the equation up here at x plus 1 over x equaling 3. I don't have it written in this form. So what I want to do is I want to get rid of the denominator. And in getting rid of the denominator, that means that I'm multiplying everything else by x. So I get a common denominator of x, and then I cancel it out. So that this would go to x over x times that. This doesn't require, the 1 over x doesn't require an x because I already have the x denominator, and then I multiply this by x over x. I multiply the 3 times x over x. So I end up getting x squared plus 1 equals 3x. Now, I need to bring everything over to one side of the equation because ax squared plus bx plus c is equal to 0. So I'm going to write x squared minus 3x plus 1 equals 0, and then I'm going to use my quadratic formula. So I'll say a is equal to 1, b is going to be equal to negative 3, that's the value that it's equal to, and c equals 1. And then I will proceed to write this out using the formula. It's negative b plus or minus the square root of b squared minus 4ac all divided by 2a, and that gives us negative 3 plus or minus negative 3 all squared minus 4 times 1 all divided by 2 times 1. And now it's just solving. So we do 3 plus or minus 9 minus 4 divided by 2, and our final answer becomes 3 plus or minus the root of 5 divided by 2. And that can't be simplified any further. So we know that our values of x are 3 plus root 5 over 2 and 3 minus root 5 over 2. These can all be turned, these two solutions can all be turned into, very easily, they can be turned simply into decimals. So you would have 3 plus 2 point something divided by 2, and 3 minus 2 point something divided by 2. Okay, I'm going to stop right there, and we'll continue on the next lesson. See you next time.